America's economic heartbeat relies on an intricate web of high-performance interstate highways.
To sustain this growth, over 40,000 kilometers of new roads are constructed every single year.
It is a massive undertaking that demands the highest level of engineering precision and industrial speed.
While many roads use asphalt, nearly 30% of the U.S. interstate system is built with heavy-duty concrete.
Concrete offers a superior lifespan, specifically designed to withstand the crushing weight of modern logistics.
These structures are engineered to last up to 50 years, twice the life expectancy of traditional asphalt.
To build these permanent arteries, American engineers deploy a fleet of cutting-edge mechanical giants.
Every millimeter is calculated, ensuring a surface that remains stable through decades of extreme weather.
From the scorching heat of the south to the freezing north, these roads must never fail.
The result is a ride so smooth, you can barely feel the transition between massive concrete slabs. Bridges and overpasses are integrated into this network, using the same high-strength material. Deep within the slab, a skeleton of steel provides the necessary backbone for this structural rigidity.
These roads define modern travel, built with a vision that extends far into the next century. Concrete also helps reduce the urban heat island effect, reflecting more sunlight than its darker counterparts.
To build at this scale, the logistics must be as flawless as the engineering itself.
The process begins with clearing the raw landscape, carving a path for progress.
It is a display of industrial pride, where high technology meets the grit of hard labor.
Construction never stops. These sites operate 24/7 to meet the demands of a growing nation.
Even in the dark, laser-guided systems ensure the terrain is perfectly prepared for the paving train. Now, let's look closer at the foundation, the invisible layer that determines the road's fate. Every great road starts by stripping away organic matter and unstable topsoil. Huge steel blades slice through the earth to reach the stable subsoil required for heavy loads. The graders then level the site, creating a massive, flat canvas for the foundation layers. Surveyors verify the elevation, ensuring the final road will drain water perfectly in any storm. Hidden beneath the road, heavy-duty drainage systems are installed to manage runoff.
Vital infrastructure, from fiber optics to power lines, is secured of deep underground before paving begins.
A padfoot roller kneads the soil, removing air pockets to create maximum density. This compaction process creates a base as solid as the foundation of a skyscraper.
Sensors provide instant feedback, confirming the ground can support the weight of the massive machines.
Next, tons of crushed stone are brought in to form the critical sub-base layer. This layer provides structural support and allows for essential moisture drainage beneath the concrete. The stones are spread with surgical precision, achieving a perfectly uniform thickness. Water is applied to reach the optimum moisture content, locking the particles together.
This hydration is key to achieving the maximum possible compaction for the stone base.
High-frequency vibration rollers then pass over, sealing the stone into a rock-hard surface.
From above, the prepared base looks like a pristine white highway waiting for its crown. Every movement is controlled by GPS modeling, eliminating human error from the grading process.
Despite the automation, physical inspections remain a vital part of the quality protocol.
A flawless base is the only way to prevent the final concrete from cracking over decades.
The surface is now ready to support the immense pressure of the paving process.
It is so stable that heavy trucks can drive over it without leaving a single mark.
The stage is set for the most impressive part of the entire operation.
Final approvals are signed off. The concrete batching plant is cleared for production.
We now move from the earthwork to the high-tech world of industrial concrete production.
Every worker knows that today's work must last for at least 2 generations.
The heart of the operation is the mobile batching plant, a towering factory built right on the site.
These silos hold thousands of tons of cement, the essential binding agent for the road.
Aggregates are fed into the system with industrial scale efficiency, guided by sensors. Computers weigh every ingredient to the gram, ensuring the perfect chemical balance. Specialized plasticizers are added to make the concrete flow easily without losing strength. Air entraining agents are mixed in to protect the road from destructive freeze-thaw cycles. Inside the mixer, the ingredients are whipped into a perfectly uniform, creamy slurry. This is a highly engineered composite material designed for maximum durability. A constant stream of trucks ensures the paving machine never has to stop. Timing is critical. The concrete must be placed shortly after it is mixed.
The wet concrete is discharged, ready to be transformed into a permanent structure.
Every batch is tested for consistency, ensuring the road remains uniform.
The plant operator monitors every variable, from water temperature to mixing time.
This self-contained factory can produce enough concrete to pave kilometers every day. Maintenance is constant. Even a small buildup of hardened concrete could ruin the next batch.
It is a symphony of industrial beauty and pure engineering functionality.
The journey from mixer to road is short, but critical for the material's integrity.
Seamless communication keeps the flow of material perfectly synchronized.
We are seconds away from seeing this raw material turned into a finished highway.
The scale of the operation becomes clear as the trucks converge on the paver.
Enter the slip-form paver, a mechanical titan that extrudes a finished road in a single pass.
It requires no fixed molds. The machine's own internal formwork shapes the concrete perfectly.
Crawling at a fraction of a kilometer per hour, it produces a flawlessly straight result.
High-frequency internal vibrators remove all air pockets, creating a dense, solid slab. This ensures the concrete reaches its maximum strength once it hardens. The screed plate strikes off excess material, leaving a surface level to within millimeters. The dowel bar inserter automatically places steel rods into the heart of the wet slab. These bars allow the road to expand and contract without losing its structural alignment. It is a mesmerizing dance of automation, placing thousands of bars with zero human error. Behind the main paver, a smoother polishes the surface until it glows like a gray mirror. A texture machine then drags a burlap cloth to create essential grip for vehicle tires. This mobile assembly line is a marvel of coordination and brute mechanical force.
Kilometers of new road are born every day, stretching toward the horizon.
From this distance, you can see the sheer power required to build a nation's infrastructure.
Sensors follow a GPS signal, adjusting the machine's height every microsecond.
The operator has total control, monitoring every system from a high-tech command center.
An auger spreads the concrete evenly across the width of the lane before the paver arrives.
The raw power of the machinery is evident as it pushes through the heavy, wet mass. The mix is so perfectly engineered that the edges do not slump, even without support.
The same technology is used for bridges, ensuring a seamless transition for drivers.
The team must be ready for any weather, as rain can be the biggest enemy of fresh concrete.
There is a certain majesty in a brand new, untouched concrete highway.
Every section is documented, creating a permanent record for future maintenance.
This is the pinnacle of civil engineering, where machines do the heavy lifting for humanity. Once paved, a white curing compound is sprayed to seal in the moisture.
This allows the concrete to hydrate slowly, reaching its full design strength.
The white color also reflects sunlight, preventing the road from getting too hot while curing.
Within 24 hours, diamond saws cut expansion joints to prevent random cracking.
These precise cuts allow the slabs to move slightly as temperatures change. The joints are then cleaned thoroughly before the final sealing process. A flexible sealant is injected to keep water and debris out of the road's foundation. This small detail is what prevents the road from buckling or eroding from below.
Weeks later, the road is opened, carrying thousands of lives every day.
The mission is accomplished. Another 50 years of service has begun.
Markings are added, and the road becomes a guided path through the darkness. But the world of road building is as diverse as the landscapes it crosses.
In other parts of the world, like Peru, the process is far more intimate and labor-intensive.
Without massive pavers, every meter of road is a victory of human sweat and manual labor.
They rely on simple tools and decades of experience passed down through generations.
It takes much longer, but these roads are equally vital for connecting remote communities. The pride of craftsmanship is evident in every hand-smoothed surface. These narrow paths are lifelines, carved into the mountains by sheer determination.
However, when nature presents its greatest challenges, humans respond with even greater miracles.
In China's Taklamakan Desert, engineers faced the sea of death to build a highway.
Moving millions of tons of sand was just the first step in this impossible project.
They used water to stabilize the sand, turning it into a foundation for the first time in history.
Massive rollers press the wet desert floor into a surface solid enough to pave over. Specialized asphalt,
designed for extreme temperatures, was laid in the heart of the desert.
The mix had to resist temperatures that swing from freezing to scorching every day.
It is a black ribbon of progress, slicing through an ocean of shifting sand.
Elaborate sand control systems were built to keep the road from being buried in days. Constant vigilance is required to keep this desert artery open. This project is hailed as a global miracle of modern civil engineering. It connects civilizations that were once separated by an impassable barrier. From high-tech automation in America to manual grit in Peru and desert miracles in China.
The knowledge shared between nations pushes the boundaries of what is possible.
Our world is shrinking, thanks to the massive effort of those who build our paths. Every journey starts with a road that someone dared to build. The next time you drive, remember the giants and the genius behind the pavement.
To the engineers and laborers of the world, we thank you for the connection.
The network continues to grow, weaving a future of endless possibilities.
Don't forget to subscribe to explore more incredible engineering feats around the globe.
The road goes on. Thank you for watching.